in summary, this this my physics model has a basic structure of 26-dimensional string theory. 26-dimensional string theory produces a lot of things that are quite interesting, one of which is if you interpret the strings as world lines, interactions between the world lines. Let's say each of these little guys is a point in space-time, and this is a history, a red history and a green history. These histories would come together and interact. They will interact just like string theory, and it will produce a type of force that is sometimes called gravity by some superstring theorists. I think they're wrong. What I do is call it the Bohm quantum potential. The interactions among these things are the interactions of the Bohm quantum potential, in my view. The Bohm quantum potential is useful in Penrose-Hameroff quantum consciousness models. Each of these particles is a little Planck-sized particle to start with. But it won't stay that way. What happens is, if you pull one little particle out, the quantum process is going to create a cloud of virtual antiparticle-particle pairs all around it. And it's going to dress itself with a huge cloud of things. This cloud has symmetry based on the string theory, quantum theory that we talked about. The quantum comes from the string theory part of my physics model. Quantum creates all this cloud here out of one little cell. Well, the symmetry of one little cell in the Planck scale in this string picture, 26-dimensional string picture, is the monster group, which is really big. It has 10 to the 53 dimensions, more or less. And the monster group has a subgroup that's related to the lattice structure, and that subgroup tells you how many particles are going to fill up this little source area here, which is called the Schwinger source area out of Julian Schwinger's source theory. Julian Schwinger's source theory was something that he did brilliantly back in the 1950s and 60s, and so people at Harvard hated it, so they ran him off, and he went to UCLA, and his source theory didn't go very far after that. If you look at the order of the group, you can say 10 to the 27th is the number of particles you should have in there. And you know the monster symmetry is 10 to the 53rd. So you have 10 to the 27 plus 53 ways that those little guys can look at the outside world. Those guys can see the outside world in terms of which one they are, and also they can look at it through the lens of the monster group. There are 10 to the 80th ways this guy can look out at the outside world. And when we were creating all these particles and antiparticles during the inflationary era here, we created about 10 to the 80th of them, roughly speaking. And that means that every Schwinger source is big enough to see every other particle in our whole universe. Everyone can see the other one. The red one can see the blue one, and you can see all the others too. And everyone can see every other one. What this means is that you have a blockchain structure. In the blockchain structure you've heard about with respect to Bitcoin and things like that, what is every Bitcoin knows what every other Bitcoin has done, and all the information is there. Well, it's just a poor copy of nature when every Schwinger source, which is about the size of 10 to the minus 24 centimeters if you work it out, every Schwinger source is connected with and can see every other Schwinger source in the universe. So everything is really more connected than anybody ever thought of because of the blockchain connection. But now, if you try to put all this information of 10 to the 80th particles in the whole thing inside this 10 to the minus 24th centimeter Schwinger source, inside one, you see that it really won't fit if you make each one Planck size. You're going to have to use a fractal structure to see how this thing works. So the structure of the Schwinger source internally has to be of a fractal nature to go down and see every one. And the fractals corresponding to each Schwinger source will be a Julia set, the central.
Why Julia set?
Because Julia sets contain information in a really neat way. The basic Julia set is just a simple circle, a disk. And if you go down and take half, small. If you do that, you go down to the limit of 256. at n equals 256, when you've gone down 256 layers, then you get enough information to fill up this. And this is just for one of the 10 to the 27 particles. What about all the others? Well, the others correspond to other Julia set pictures, like this, all the way down. They go the same way, symmorphic. And the Mandelbrot set organizes all these guys into a nice way where each one is identified by a particular Julia set. That way, each one sees the others as a Julia set, and they have their own personal characteristics, and they know each other. And when they see in here, when they connect up here, they can see which Julia set they're looking at in there. So that's where the monster set group is useful. And
the Mandelbrot set or the Julia set, I believe it's a good picture of what is a fractal, but the real fractal which appears naturally in the model is the quasi-crystal fractal, so the infinite deflation in any quasi-crystal, in the Elzerson quasi-crystal.
That's why I go down 256 levels and stop.
No? When you stop, you can go further.
Well, I don't need to go further to get all the 10 to the 80th particles of the universe inside each Schwinger source.
Well, we're looking at Schwinger sources a little bit differently.
Yeah, nobody agrees with me on this. This is just my view. So
we agree with the idea that this is fractal, but it's not a Mandelbrot or a Julia set. It's a quasi-crystal, which is self-similar by nature and not finite.
Well, I haven't gone to that level yet. I'm talking about on my 8-dimensional level now. I'm still playing in 8 dimensions, either octonionic or 4 plus 4 Kaluza line, quaternionic. I'm going to get to quasi-crystals later. I haven't gotten to them yet.